Hi guys, in this video we're going to talk about the diencephalon. So what is diencephalon? Di means across, encephalus or cephalon means brain. So you have a structure that lies across the brain which serves as important processing center for information. And you guys know that this is the relay station for information coming between the cerebral cortex and other structures around it. So it lies across the brain and it's surrounded by the cerebral hemisphere. So in order for me to see the diencephalon here that lies across the brain, this is the meaning of the word, I need to remove the cerebral hemisphere to see it. So it lies, we talked about the deep group of nuclei lying at the base of the brain. That was the basal nuclei, right? And we talked about the limbic system, groups of nuclei deep in the brain. And now we are coming to the diencephalon, which is somehow related to them at the base of the brain. And these are again the group of nuclei, cell bodies that lie within the tracts going up and down and forming your brain all around you. So it lies across the brain. That's what we mean by diencephalon. So what are the parts of the diencephalon? We have the thalamus, and then we have the hypothalamus, and hypo means below the thalamus, and we have the subthalamus, which is basically a continuation of the tegmentum of midbrain. It has those lemnisci that coming up from down, all right, like the medial lemniscus, spinal lemniscus, trigeminal lemniscus. These are the tracts within the subthalamus. And we also have nuclei, and these nuclei are related. Remember when we talked about the basal nuclei and how the subthalamic nucleus is at a relation with the substantia nigra, and how we have it involved in the indirect pathway. Remember that? So when we say that the subthalamus has nuclei, these are 3 nuclei. Parts of them would be superior parts of the red nucleus. It would have parts of the substantia nigra, upper part of substantia nigra, and the subthalamic nucleus that we talked about it in the basal nuclei. So this is basic information about the subthalamus, and I said it here because I don't have a separate explanation for it. It's just we talked about it in the basal nuclei collection, and you just need to know that it's part of the diencephalon. So you have the thalamus, you have the hypothalamus, and what separates them is the hypothalamic sulcus, all right? And then you have the subthalamus, and you have the epithalamus, which is basically part of the pineal gland, okay? It's the habenular nucleus and the pineal gland is what makes your epithalamus, and we talked about that also in the limbic system, right? So in today we're gonna, in that video, we're gonna talk about the thalamus, its relation and basic function of the nuclei, and we're gonna talk about the hypothalamus, anatomical relations and basic function of its nuclei. All right, so starting off with the thalamus, I want you guys, when you think about the thalamus, that you think that it's a structure that lies at somehow the center of your whole thing. And you guys know that we have the ventricles that is basically inside our brain. Okay, so you have above the lateral ventricles that have the anterior horns, the body, and then laterally you have lateral and down. I'm saying lateral because it's not related to the thalamus, it's in the temporal lobe, it's lateral, and you have the inferior horn and you have the posterior horn in your occipital lobes. I just want you to know that the thalamus is going to be here around the 3rd ventricle, all right? So you need to have this in your capture it. You need to envision this in your brain when you want to study the thalamus and hypothalamus here, because it's so much related to the 3rd ventricle, which at the center of it, I mean, if this is my thalamus, then the space here between this thalamus and the other one, which has been removed in this mid-sagittal section, it's going to be the 3rd ventricle. So here in this, you have the thalamus and the hypothalamus, and you need to know that the medial relation for them is going to be your third ventricle. And above relation to the thalamus would be the lateral ventricles, the body of the lateral ventricle. So I just want you, when you want to study the relations of thalamus and hypothalamus, to remember that you are lying around the third ventricle and below the body of lateral ventricle. And don't think about the other parts of the lateral ventricles because they are far away from you. Okay, these are in the hemispheres, and remember, this is in the center, so this is far away from you. Okay, so what would be the relations of the thalamus? If I told you guys that you are here in the thalamus, and I'm telling you that you are surrounding the third ventricle, so what's gonna be in front of you is what we call the interventricular foramen. Remember that we have a foramen that is a communication in the third ventricle, and already you know that the third ventricle is a space in the thalamus. This is the space, and this is the thalamus. So if I have a foramen that is in front of my thalamus, this is going to be the anterior relation. It's the interventricular foramen. Why? Because you guys know that the thalamus is surrounding the third ventricle. So what's going to be in front of it? It's going to be the interventricular foramen. Okay, what else do we have? I told you guys that this is the thalamus and it's the center. So what's below you is going to be the hypothalamus, and you guys know that this is the hypothalamus and it's related to the pituitary down. All right, so this is the hypothalamus, and the subthalamus is below you as well, because hypo and sub means below. All right, so what's going to be below you is going to be the hypo and subthalamus, and also metathalamus, which is the geniculates. All right, so major structures lying inferior to the thalamus is very common sense, hypothalamus and subthalamus, which is continuation of the tegmentum of midbrain. Okay, so the hypothalamus and subthalamus. This is what lies below the thalamus. All right, what is superior? You guys, I told you now that what lies superior to you is the body of lateral ventricle. Is that what we all need to know? No, guys. If you guys look at the coronal section, and you know that from our cutie cat and the basal ganglia, that was the lentiform nucleus, that was the chordates, and I told you the thalamic nuclei are at the center, and I told you that they are surrounding the lateral ventricle. So the lateral ventricle is your medial relation. What is above you, we made a deal that it's the body of lateral ventricle. Is that all we need to know? No, guys, because the body of lateral ventricle, or any dilatation in the ventricular system, you need to know that there is a choroid plexus that is forming the CSF that swims in those ventricles. So what would be a superior relation to you other than that the body, what forms the structure that swims in the body, which is the choroid plexus? Is that all I need to know? No, guys. You remember when we talked about the limbic system, and we said that the fornix comes all the way and it surrounds the thalamus medially and superiorly. So that you need to know that your fornix is in the superior relation to the thalamus. So what is the superior relation to the thalamus? It's the lateral ventricle, the body of lateral ventricle, the choroid plexus that forms the CSF in it, and also you have medially and superiorly the fornix, right, guys, that lies superior to the thalamus. All right. Now, what is in the medial side? Very easy. I know that the thalamus surrounds my lateral ventricle. So this is the thalamus. So medial surface, I will have the third ventricle. And it's going to be also the same for the hypothalamus. Also the medial surface, the medial relation to the hypothalamus is also the third ventricle. Because you guys know that the thalamus and hypothalamus, they surround the third ventricle. When I refer to the Kinhop picture, I'm referring here to the ventricular system. I don't have here the structure. When I refer to the picture of the Netter atlas, I'm referring to the structure itself, which is the thalamus and down the hypothalamus. All right, guys? So what is in the medial relation to the thalamus? It's going to be the third ventricle. What's going to be in the lateral relation? Oh my God. Do you guys remember the basal nuclei? Remember that I told you have here the thalamus medially, and you have the lentiform nucleus, and what separates them in the internal capsule? All right. So lateral to the thalamus, you guys, is going to be your internal capsule. And lateral to that, you have the lentiform nucleus. Right, so the thalamus has laterally the internal capsule, and lateral to it is the lentiform nucleus. All right, this is in the lower part. And in the upper part, you have the caudate. Remember, guys, when I told you also in the limbic system, because I wanted you to understand what happens deep in the brain with this very nice superior view dissection, I told you that the thalamus has structures that are looping around them. Remember when I told you the fornix loops around it from down to top medially, and this is a top relation to it. And I told you that the caudate nucleus, it wraps around the thalamus laterally. So what's gonna be related to the lateral surface in the top is gonna be the body of caudate. So this is the thalamus. Lateral to it is the body of caudate, and also in coronal section you can make out that the lateral surface superiorly is related to the body of caudate nucleus, and lower it's in the lentiform. So it's all related to your basal nuclei, people, and separates them from the lentiform is the internal capsule. Why I'm saying again the internal capsule? Because it's also a lateral relation to the hypothalamus, because so many of the relations of hypothalamus and thalamus are the same, especially the medial ones and lateral ones. But superior and inferior, it's different, of course. Now, coming to the nuclei and their function, what would be the function of the thalamus? You guys know that the thalamus is a relay station. It's the secretary of the cerebral cortex. It means that if I am processing information, it needs to go through a group of nuclei. The secretary will take that file, it will put the information of that file in that group of nuclei, and every one of them knows where to go. All right? Now, how can we remember the nuclei? Already, guys, by now, we have covered most of the nuclei of thalamus. And I'm going to remind you now how we covered most of them and how to remember the rest of them. Now, what have we covered so far? Remember, guys, when we talked about the ascending tracts and we said that the VPL is what takes information to the sensory cortices. Remember when we had the spinothalamic tract and all those guys sensory coming from the body, they go to VPL nucleus of thalamus, and from there they go to the sensory cortex. Okay, so VPL is responsible to take information to the sensory cortex from the body. What about VVM? All right, they look the same, but M is from trigeminal, so it brings information from sensation of your face. All right, guys, so VPL and VPM, we know them. They bring information from the tracts to the sensory cortices. VBL from the body, the tracts, ascending tracts. VPM, sensory information from trigeminal nerve, and this is sensory information from the face. So this is the body and this is the face. And they take the information to the sensory cortices. All right? And what about the geniculates? Remember when we talked about the superior and inferior colliculus, and I told you guys, remember that the superior colliculus is your eyes, all right, and inferior colliculus is your ears. So the superior colliculus brings, it's the visual center, and the inferior colliculus was the auditory center. I have, after the superior colliculus and inferior colliculus and the midbrain, we need to take the information to the secretary so that we can proceed to the big boss, right? Regarding the light, L, it needs to go to the geniculates. Okay, so the colliculi takes care of vision and audition, and they will take them to geniculates as well, right? Medial and lateral geniculate bodies in the thalamus to take the information to the cortex. So which one for which? We have medial geniculates and we have lateral geniculates. L for light. L for light. So this is responsible for the visual pathway. And M for music. So this is responsible for auditory pathway. And from there you will take it to the auditory center in temporal lobe. And from the light you will take it to the occipital lobe visual center. All right, guys. So by now everyone knows VPM and VPL, sensory cortices from the body and face. Geniculates, audition, and vision. All right, what about the dorsomedial nucleus of thalamus and anterior nucleus of thalamus? Do you guys remember the limbic system? Talked about the limbic system, and we said that the anterior nucleus of thalamus is what takes the information in the Papez circuitry to the cingulate gyrus so that you can process the information in learning and memory. And we also said that the dorsomedial nucleus of thalamus takes the information and processing into the prefrontal cortex so that you can form a thought, an idea, and learn. Okay, so DM and anterior nucleus, we already talked about them in limbic system. And we can add to this that the dorsal people, whether it's medial or lateral, they are responsible for limbic system. Okay, so the anterior guy and the dorsal guys, medial and lateral, it's related to limbic system. VPM, VPL, sensory cortices, geniculates, audition and vision. The VA and VL, the consultants, these guys, the ventral lateral and ventral anterior nucleus of thalamus, are our consultants. Who are our consultants? Who do we consult before we form the motor function? Remember, guys, the basal ganglia and cerebellum. These are the people we need to send them information about the planning of the movement, and they will control our movement. The basal ganglia and the cerebellum. So VA and VL are our consultants. They deal with the consultant information. The VLL cerebellum and the VA is basal nuclei. Double L in cerebellum. So VL is having connections with cerebellum, and the VA, all right, the basal nuclei. All right, and the internal medullary lamina, it has to do with the reticular formation and level of consciousness. So by now, you guys remember all the nuclei of thalamus and what is the basic function of those guys. This is another picture which shows you where the information is going. I liked it. I'm not going to explain it because everything is explained in its respective video. I just want to recap with you guys the nuclei. So remember that we had the anterior nucleus of thalamus, we had the dorsal people, medial dorsal and lateral dorsal. They were responsible for limbic system. That was regarding limbic system. All right, so remember that was these nuclei were related to limbic system, and we already explained them in the limbic system. And we also talked about the VPL and VPN, which was for the sensory cortices. VPL were the body, VPM with the face. Remember that the VA and VL were to our consultants. Okay, so these are taking information from the cerebellum. This is the relay station between the cortex and the cerebellum, and the VA basal nuclei and the cortex. Okay, because everything needs to go to the thalamus before we process it into the cortex. And then we had the medial geniculate and lateral geniculate. Where is the lateral? Lateral geniculate body. All right, so these ones were for M for music. All right, so this is the auditory pathway, and this is part of the visual pathway. And pulvinar is the posterior part of the thalamus, which holds the geniculates. All right, so and that's the recap of the nuclei of thalamus. All right, guys, I think it's easy because we